Alright, good afternoon to everyone. Can I get a confirmation that you guys are seeing the screen? You hear me clearly? You guys hearing me? You hearing me? You seeing the screen clearly?
Yes, sir.
Alright, good. So, where are we currently? We're finished with the first three topics: computer fundamentals, networking, and the implications of misuse and cybersecurity. We're going to be skipping over these three until Monday, tomorrow. So today we'll start with problem solving, algorithm, flowchart, pseudocode, trace table, variables and constants, conditional statements, relational operators, and so on. So remember, once again, the session is for you guys. So I will be going a little fast. So if you need me to repeat something, let me know. If you have a question, let me know. You can unmute at any time and let me know what's your question, or you can just type it in the chat. Anyone that works for you. Alright, so let's get started. Now, introduction to problem solving. Why are we looking at problem solving? Each and every day, we have problems in our life. And this is not only for programming. We have problems that we face daily. For example, you wake up late in the morning. You have to go to school for 9 o'clock in the morning, and you wake up late. That's a problem there. You normally wake up at 7 o'clock, do all your chores, and get ready, eat, bathe, shower, everything that you need to do. But this one morning, you woke up at 8:30. That's a problem there. Now, problem solving is basically trying to consider this problem and what can you do about this problem. What are the series of steps you should follow when you are to try to come up with a solution to this problem. So say, going back to the same problem, you wake up in the morning, it's 8:30. Now what do? What are some solutions to that? You don't eat, you don't bathe, you just put on your clothes, you run out of the house. That could be one solution. Or another solution, you just stay home. Or you go to school half day. You do everything that you normally have to do, and you go to school half day. So everything that we encounter in life, we can consider it as a problem, and we always try to find a solution to that. So that is the idea of problem solving. Now, software is the name given to computer programs that tell or instruct the hardware how to work. So software therefore includes computer programs that create system and application software. And each program exists because a problem first existed and a solution was needed to solve that problem there. So, for example, accountants, they have to do balance sheets, they have to do all of those financial records. So, they realize that what can we do to make this process faster? So, they decided to come up with applications that can help them to make these tasks faster. So they came up with Microsoft Spreadsheet, QuickBooks, those kind of applications that would allow you to process your data faster. So you have a problem and you're coming up with a solution to that problem. Now, solving a problem. You should first develop an algorithm to solve a problem. So you have a problem. What are you going to develop to solve this problem? An algorithm. What is an algorithm now? An algorithm is a sequence of precise instructions that that will result in a solution that you're going to follow that will lead to a solution. The key word here, it has precise instructions. It has to be clear as to exactly what you're going to do. Say, for example, the problem is that we are hungry. The problem is that we are hungry. What is the solution? Obviously, to try to get something to eat. But how are we going to get something to eat? That is the algorithm. What are you going to do? You have to be clear. You're going to go to the supermarket, you're gonna buy bread, you're gonna buy butter, you're gonna buy all the ingredients that you need. You need to list all of that in your algorithm. You need to say how you get into the supermarket. You take a train to the supermarket, you take a plane to the supermarket. How are you getting there? Then you go and purchase the items. How are you purchasing it? With a credit card, with a debit card, with cash. Then how are you getting back home? You're taking a taxi back home. Now we get into the part of making the food. How are you gonna make the food? You gotta say exactly what you're gonna do. Put the ingredients on the counter. Take out a plate. Take out a knife. Open the bag of bread. Take out 2 loaves of bread. Put it on the plate. Open the jar of butter. Take knife and scoop out some butter from the jar, and then spread it onto the bread. So everything that you're explaining in an algorithm must be precise. It must be clear. Why it must be clear is because if someone else is to look at this algorithm, they must know exactly what they have to do. So basically, any person should be able to follow this algorithm. That's how clear and precise it should be. Are you guys clear on everything I just said?
Yes, sir.
Great. Now, so that means your algorithm should not be vague. It should not have any conflicting logic. So when you read it, you shouldn't be questioning yourself, what do I have to do? It should be clear. Now, what are the phases of problem solving? Well, we have 2 phases. We have the algorithm phase, and then we have the implementation phase. So remember, first we have a problem. So the first step, we have a problem, something that we want to solve. The next step is to develop a algorithm. How do you we're going to look at how to carry out that algorithm. So if you notice, it's actually broken down here. So the first step whenever you're coming up with a solution is to clearly define the problem. What is the problem? I'm hungry. How is that affecting me? It's causing me to be irritated. It's causing me to be upset. I'm always angry. I'm feeling weak. That's how you define a problem. You identify what's the problem and what are the causes and effects of that problem. Now, the second step, you're going to propose some solutions. What are some solutions to this problem of being hungry? You're going to buy some food. You're going to make some food. You're going to go by your friend or your family or by your grandmother and ask her for some food. You list various solutions. And then next, the third step, you choose the most suitable solution. So out of all of these solutions, which has the most advantage? If I go and make the food, that means I gotta go and spend money. I gotta go and spend time and energy to make this food. But if I go by my grandmother, I can get food right away. She can make it for me. I just gotta sit down and wait on the food. But do I want to wait on the food? So all of those, whenever you propose solutions, you look at the advantage and disadvantage of it, because that will help to determine which is the most reasonable solution, which is going to be the most effective one. So after you finish coming up with a solution, now you have to design an algorithm now that is going to help you develop this solution. And remember, we just said the algorithm is the steps you're going to take to solve this problem. And then finally, you test that algorithm. So these are the 5 steps that you basically follow when you are coming up with a solution to a problem. You define the problem. Well, before, you have to identify the problem, and then you define it. Then you propose solutions to those problems. You look at you identify various solutions, and at step number 3, you analyze them. You say, what is the advantage, what is the disadvantage of each, and that will help you determine which is more reasonable. Then whichever solution you pick, you have to design now an algorithm for it. What are the steps to reach this solution? And then you test that algorithm. Before you even go and implement the solution, you test it to see if it is going to work, if it is even possible, if it has some sort of mistake or some sort of error inside of it. That is the algorithm phase. Now, after you're finished with all of that, you enter the implementation phase. You put the solution into action now. You already tested it. It's okay, it's fine, it can work. But now we need to implement it now. Now we need to carry it out. So at this phase here, when you finish creating the algorithm, you translate, you convert your algorithm into a programming language. What are some of the basic programming language that you need to remember? We have Basic, we have Pascal, we have C, and Visual Basic. Please do not confuse these two here. They are different programming types. Basic and Visual Basics are two different ones. We have C+, we have C#, C++, we have Python, we have Java. Those are the common programming languages. So on your exam, they might ask you which of the following is not a programming language. That's why it's important to know what are the examples of programming languages. So in the implementation, the first step, you convert your algorithm into a programming language. Why we say convert? Why do we say translate? Because the steps in the algorithm should be so simple, should be so clear once again, that it's easy for you to just translate. It's like if you're translating from one language to another. That is how simple it should be. Now, after you finish translating into that programming language of your choice, you execute the program. You run the program, make sure it is working, functioning as you would like it to work. And then the final step, you maintain the program. Maintain or maintenance of the program. If it has any bugs, it has any errors, you try to fix those mistakes in the program. 1 month, 1 year after you release the program to the world, and some bugs and errors are coming up, and you send out updates, that is called maintenance. So, and even adding additional features, even if something is not wrong, adding additional features to a program is also maintenance. So, once again, these are the steps you follow when you are implementing a solution. Identify the problem, define it, propose the solutions, find your most reasonable one, design your algorithm, test it, convert it into a program, execute the program, and then carry out maintenance on that program. Are you guys clear on everything so far? Any questions?
No, sir.
Alright, so now how do you define a problem now? Well, when you first analyze a problem, you should specify what is your objectives. What do you want as to come out from this solution here? That is what the program is meant to do. So the following 4 steps is going to organize or summarize what you want to be the outcome. The first step, specify what is the output. When you're running this program, what do you want to be the output? Do you want what kind of output are you expecting? Will the output be numbers? Will it be text? Numbers and text? Will it be something graphical? Will the output be in a form? However, will it be soft copy? Will it be hard copy? When you specify your output, you will know what is supposed to be the outcome. Specify what is the input. What data, what values do you need to put into the system for it to process and give you necessary output? And then more so, what devices do you need to put in the data? For example, if you need to type information into the program, you need a keyboard. If you need to transfer data, you need a storage device. If you need to speak or to transmit sound into the program, you need a microphone. So you need to specify what is your input. Now, third, you specify the processing. What are you going to do with this input to give you your necessary output? How are you going to process this data now? So what calculations do you need on this data? How should it manipulate this data now to get you your outcome? So we talked about the various types of processing: batch processing, real-time processing, time sharing, and the other one, those can be specified here to determine how the data will be processed. And then finally, you specify how the data, how your output is going to be stored. This is not always necessary because you don't always have to store the outputs. You don't always have to. It could just be something appearing on the screen. You add two numbers together, you multiply two numbers together, and the answer appears on the screen. You don't have to save it. But if you do have to save the data, you will specify how is it going to be stored. Is it going to be a temporary output, or is it going to be stored permanently? So that is how you define the problem. If you notice, that is actually step number 1 for the algorithm phase, defining that problem. You look at what is the output, what is the input, what is the processing you need to carry out, and how are you going to store your data. And if you guys can remember, that is basically IPOS cycle, because that is how your computer functions. Now, before you develop an algorithm, it is recommended that you develop what is called an IPO chart. IPO basically stands for input, processing, output. Now, IPO chart is not a chart, it's basically a table. So as you can see in the right hand side here, it's basically a table. A table that lists what? I for input, P for processing, and O for output. Why are we listing this here? Because if you notice, so far we've been talking about when you define a problem, you have to know what are you going to input, what are you going to process, what are you going to output. So if you take a small table and you just list it exactly where you want to go into the program. For example, you want the program to calculate the average temperature. So you just simply list, what do I need to put into this program to give me my average? I need to put in 2 temperature, or how much of a temperature I need to put in. And so in this case here, a maximum temperature and a minimum temperature, that is going to be entered into the system. That is my input. You just list in what are you going to put into the software, what are you going to put into the computer. Next, what are you going to do with this input now? How are you going to process it? What is the calculation? Max plus min divided by 2. That gives you average. Or even if it was multiple here, you would see the calculation adding up all of the temperature and dividing it by how many temperature was actually entered. That is the processing. And then output, what do you want to appear on the screen? What do you want as your hard copy or your soft copy output? You want the average temperature. So the IPO chart, as I mentioned, is not a chart. It's just a table with 3 columns, and it lists the input, the output, and the processing. Why do we list that? Because it can help us when we are creating an algorithm. We will know exactly what we need to put as input in the algorithm, exactly what we need to put as processing in the algorithm, and exactly what we need to put as output for the algorithm. So we have another example here of an IPO chart. Remember, it's just a simple table. So if you notice here, the input is 3 numbers, number 1, number 2, number 3, and these here are variables. Remember, there's that is how we store our data in a program, in a software. We store it into variables. So we have 3 variables here that have 3 values inside of them, 3 numbers. Now what is our processing? Add 3 numbers together. So you don't have to create the entire formula. You can write it in English words. What is to be carried out? Because remember, we have to be clear. We have to be specific. So if this is how you are clear, this is how you're specific, that can work also. And then the result of the addition of these 3 numbers here. Great. So that brings us to the end of that chapter there. What did we look at? We look at what is problem solving, what is the algorithm phase, what is the implementation phase, how do you define a problem, and why is the IPO chart necessary for the creating of the algorithm. Are you guys following along there?
Yes, sir.
Great. Now, algorithm design. How do you design an algorithm? Well, we need to have the theoretical knowledge first as to what we put into the algorithm. So that's what we'll be looking at now. So to help the simplification and development of the programming problem, algorithms can be created as a pseudocode or flowcharts. So we have two methods of creating an algorithm. We either create a pseudocode or we create a flowchart. Now, an algorithm is a step-by-step instruction. Remember, it's a precise step-by-step instruction. You must be very clear with these steps that you're going to carry out to solve that problem. So, but it must follow some rules. Even though you can write it clear however you want to write it, it's still important that we have some guidelines when we are creating this algorithm. So that's what we're going to look at also. So it must follow some rules, it must be explicit, and it must have a clear stopping point. So it must be clear where the algorithm is starting from, and it must be clear where is the ending of this algorithm. Because what we put in the algorithm is not only the steps, we could put additional information, what we call comments. And these comments can basically give additional information to whoever is reading the algorithm. So that's why it's important to indicate where is the starting and where is the ending. Now, it is really used to expand the processing part of the IPO chart. So it expands upon the IPO chart. Now, the flow chart uses diagrams. What are some examples of that? Let me quickly show you. The flow chart uses diagrams. So as you can see here, these are the shapes and diagrams that the flow chart would make use of. Now, and as you see here, it uses these shapes to show the flow of the starting point to the ending point of that solution. Whereas the pseudocode is going to be English words, English statement. You're going to write in normal everyday words, but it's not only English. It doesn't. It's just because we know English, we're going to write it in English. But the pseudocode can be in French, it could be in Spanish, it could be in any language that is known by that person. But we know English, so we write it in English. But the key point, it's written in words that the person will be able to understand. So pseudocode is written in words and the flowchart uses diagrams. Now the algorithm, it should start with a title. This part here, that is how we can tell where the algorithm is starting from. When we see a title, that is how we indicate the starting of an algorithm. And when we see the keyword end, that is indicating the end of an algorithm. So we don't see start, and that indicates the start of an algorithm. The title indicates the start of the algorithm. Now, developing a program can be a major undertaking, so good algorithm design is very important. It is not always possible to satisfy all requirements, so obviously you're not going to develop a perfect algorithm in the very beginning, but it's basically for you to put the main steps that you think you're going to need to carry out the solution. So some problems may be complex, hence they're going to need a complex solution. However, there are some general goals in designing an algorithm. One, your algorithm must be correct, so it should accept all inputs. So these are some rules and guidelines when you're creating an algorithm. One, it must be correct. What we mean by correct, in that it should accept any inputs and be able to give you a meaningful response. What do we mean by that? say for instance your algorithm, your program is to multiply numbers. So your program is designed to multiply numbers. 2 times 2 gives you 4. That's the purpose of your algorithm. Whenever you enter two numbers into your algorithm, it should be able to calculate it. Now, say for instance, so we know this program, this algorithm is to accept numbers. Now, what if the person put in letters? What should happen? The program should just crash just like that? No, the program should not crash. It should not. What it should do is give you an error message. It should give you a meaningful response. It should tell you that, look, error, numbers are required for the calculation. That's simple. So it should be able to accept all inputs, and whatever is a wrong input, whatever is invalid, it gives a meaningful message. It tells the person that, look, that was a wrong input that you made. I need numbers. 2, your algorithm should be simple. Each step of the algorithm should perform one logical step. What we mean by that, if we look at an actual algorithm design, so in this example here, notice each step. So this is step 1, step 2, step 3, step 4, step 5. If you notice, they're all performing one logical step. So the very first step is to input the number 1, second step input number 2, third step input number 3, and so on. So we don't group a lot of activities into a single step. 2, 3. The algorithm must be clear. As we said, it must be precise. Any person should be able to read it and be able to understand exactly what is happening. 4, the algorithm must be precise. The algorithm should represent the solution steps precisely and concisely without referring to low-level programming code. What is low-level programming code? Low-level refers to zeros and ones, which is basically binary. Or there are also some other low-level programming languages. Let me see if I find some examples quickly. So this here is also important to note. The various levels of programming languages. So we have a programming language at the very top, and we have 3 levels of programming languages. We have the low-level language, we have the middle-level language, and we have the high-level language. Now, the high-level language is what you can understand. High-level language is what you can understand. So if you notice the examples at the bottom here, you have COBOL, Fortran, Pascal, C, C#, Prolog, Java, .NET, and so on. So these are languages that you understand, and that means the computer does not understand it. Because what actually happens is that even though you write in a high-level language, it has to be converted to a low-level language for your computer to understand it. Your computer only understands low-level language, which is also called machine language. That is all your computer understands, which is basically binary, which is zeros and ones. That is all your computer understands. So what we're saying here is that the higher the programming language is what you can understand, the computer cannot. Thus, the lower, you cannot understand it. Only the computer can understand it. So, with that in mind, that's why they say here, you should not reference or refer to any low-level programming code. Because another person, even if you put it in, another person will not be able to know what is this code. For example, if I type in 01000100, you don't know, I don't even know what that is. So we should not make use of it. The next point, the algorithm must be easy to implement. So this basically refers to the points above. Once we're simple, once we're clear, it should be as simple as translating one line after another into the programming language. So you just look at step 1, translate it into the programming language. You look at step 2, translate it into the programming language. Should be that simple to implement the algorithm. And then lastly, the algorithm must be efficient. The algorithm should enable the program code to produce results quickly, depending on the problem size, and not waste any memory. Basically, the algorithm, the program, it should function quickly, should function effectively. You shouldn't have to wait too long to get a result from the output of that algorithm or that program. So that's what is meant there by efficiency. You should be able to get your results quickly. Are we following so far? Are we keeping up?
Yes, sir.
All right. Remember, once again, you have any questions, you have any comments, anything, let me know. Good. So let's continue. Now that you've been introduced to algorithm, you should become familiar with some terminologies. These terms apply to both pseudocode and flowchart. Now, firstly, two very important terms you need to understand. What is a variable? What is a constant? Now, they both are basically the same, just that they function differently. The purpose of them is to store what is input. A variable or constant is an area or space in memory that is going to hold some form of data that the program is going to need. That is all that is the purpose of a variable or constant, to hold data. You're going to say your program is to add numbers, your program is to multiply numbers. Who is going to hold these numbers? Where are these numbers going to be stored? They are going to be stored either in a variable or a constant. Now, what is the difference? So that's what they are. The purpose of them is to store data, to hold data, so that the program can make use of it. Now, what is the difference between the two? Well, the word variable, you should think of the word vary. It changes. So that means this type of container, you can call it a container, this type of container varies. It can change. So if I put 1 inside of it, I can change it to 2. I can change it to 50. I can change it to 100. I can change it how much every time I need to change it. I am allowed to change the value in a variable. Whereas in a constant, I am not allowed. As the name implies, it is constant. It remains the same at all time. So this is useful when you want a value to remain the same. For example, pi. Pi does not change. Pi is 3.14 all the time. Tax. Whenever the government issues tax for any particular item, it's that one standard tax. Maybe years after, and then that value actually changes. So right now, maybe we're around 40% tax. So that could be a constant. A person's year of birth, that will never change. So you can make that a constant. So basically, if a value will not change in your algorithm or your program, you store it in what is called a constant, because you want that value to remain the same. But if you want a container to change its value, we use what is called a variable, so that value could be updated. Now note, a constant is a type of variable. That's what I said earlier. They're basically the same, just that they function differently, because both of their purpose is to store data, but one stores it permanently, and you can say one basically stores it temporarily, because it can change. Now, as I mentioned, the value in a variable can change throughout the algorithm. So examples of variable, number and total. Each variable is given a name so that you can assign values such as numbers or text to that variable. So remember, a variable is used to store data. It can be any data. Well, not graphical data. It's a bit mainly numbers and text types of data. So words, phrases, all forms of numbers and signs and symbols, they will be stored inside of a variable. Now, what are the types of variable? So whenever you're creating a variable, you do two things. One, you give the variable a name, and two, you give the variable a type. So you give the variable a name, for example, number one, number two, or the total variable, the average variable, and then you have to give that variable a type. Why you have to give it a type? Because you only want this variable to store a particular type of data. So what are our types of variables? We have 5 main types of variables. We have integer, which is basically a whole number. It could be positive, it could be negative. Now in relation to that, we have a real data type. Basically the same like an integer, but the only difference is that we can store fractional numbers. We can store numbers with decimal places. So integer is only for whole numbers, and a real, well, obviously that can accept whole numbers also, but it will facilitate having fractions, having decimal places. So that's the only difference there, having decimal places. Now we have two other relating data type. We have character and we have string. A character data type is basically a single letter, a single symbol, a single punctuation. So like for example the letter G, the letter B, the asterisk, one single character. That is the purpose of the character data type. Now when you want a collection of characters, when you want a word, when you want a phrase, that is when you're going to use a string, because a string is a collection of characters. So any word or phrase, you would use a string data type. And then lastly, the Boolean data type. This data type is when you only have two values. For example, the value can either be true or false, yes or no, male or female, on or off. So once it has only two states, two value, you can make use of a data type called Boolean. So once again, a variable, a constant, they're used to store data, text and numbers. A variable changes, constant remains the same. Whenever you're creating a constant or a variable, you need to do two things. One, give it a name. Two, give it a certain type, because you only want that type of data to be in that variable. Now all variables must have a meaningful name. What do we mean by a meaningful name? Whenever you look at the name, it should tell you exactly what type of data is inside of it. For example, persons would name the variable VAT, because one look at that, you already know it is VAT. They would name it discount, because one look at that, they know it is discount that is being stored inside of that variable. Good. Hope you guys are following so far. Remember, if you have any questions, need me to repeat anything, just let me know. So we're moving on to what are statements and keywords in your algorithm. So remember we said earlier that your algorithm is going to have certain rules that we must follow. One of those rules is making use of statements and keywords in your algorithm. How do we make use of statements? And even naming your variable, giving it a certain type, those are actually rules that you would follow. So what are these names and keywords, statements and keyword? Well, a statement is a description of the processing that includes an action or condition. Basically, a statement is the action that is being carried out. It tells you what sort of action is being carried out in the algorithm. Now, instructions within the statement, we call those keywords. So examples of keyword is input, read, output, display, print, and write. When you look at them, they tell you exactly what they're doing. So let me underline these four in different colors. So output, display, print, and write. So whenever you use the keywords input and read, that means you are putting data into the computer. Input and read, those are keywords that you use to indicate you are putting data into the computer. Whenever you use keywords like output, display, print, and write, that indicates you are getting data out of the computer. You're putting data on the screen of the computer. So, input and read, it's indicating input. Output, display, print, and write, those are indicating output. Now, another type of statement is called the conditional statement. It gives you a condition. Now, conditional statement allows decision to be made. It allows you to make a decision. So this includes deciding which statements, so you decide which statements are to be executed or carried out. For example, so say for example, you guys might have a condition. Why is it called a conditional statement? Because you have what is called a condition, or I like to say a test. You have a condition or a test. You might have a test like is 600 greater than the variable total, and inside of total might have a value of 400. That's a condition. That's a test. If 600 is greater than total, if it is less than total, if it is equal to total, that is your test, that is your condition. And based on that, you make a decision. Do I go left? Do I go right? Do I go in the center? Where do I go? What do I do in the program? So that is basically the purpose of a conditional statement. You carry out a condition, you carry out a test, and based on the result of that condition or test, you take a different path in your program. And the name of this conditional statement is the if statement. The if statement is what allows you to have your condition that is going to create your various paths in your program. Now, the next type of statements that we have in our program are called loops. The purpose of a loop is basically to repeat a part of your program. You might have a certain part of your program you want to repeat, like for example, to repeat the part of the program that is accepting inputs. Maybe you want to accept 100 numbers. So instead of writing input number 1, input number 2, and all the way to 100, you minimize the line of code by implementing a loop. So whenever you want a certain part of your program to repeat, you do not copy and paste it. You put it around a loop. You put a loop around it so that that part of the program repeats itself without you having to increase the lines of code in your program. So that is, they will repeatedly execute a section of your program until the condition is satisfied. So each loop has a certain condition as to whether you will stay in the loop or you will exit that loop. In order to exit from a loop, you must have a method for checking to see if you have completed the task. So they have a condition and they have a method of testing that condition, if you would have fulfilled that condition. Now once a loop terminates, control is returned to the first statement after the block of statements. So let me show you what is meant there. So say for instance this here, this box here is your program from start to bottom. Now at the top here you have some lines of code. Now in a box I'm going to have some more lines of code, but this box here represents a loop. So a program functions logically. It goes one step after each other. So it goes step 1, step 2, step 3, or line 1, line 2, line 3. It goes in that logical order all the time from top to bottom. So when it enters this loop now, step 4, step 5, and what's going to happen here now, it's going to loop around in here all the time, repeating 4 and 5, 4 and 5, 4 and 5, 4 and 5 all the time. And then when it does come out of the loop, it continues with 6, it continues with 7, it continues with 8. That is how a loop works. It repeats that part of the program, and if the program still has more lines of code, it will continue with those rest of lines of codes. Now, what is a subroutine now? For when you have a large program, it's easier to work on small sections of that program by separating the algorithm into individual sections. So, a subroutine is basically breaking up a very large program into small individual parts. Companies do this a lot today. They break up a large program into parts so that person 1 does this part, person 2 does another part, person 3 does another part, so that everyone does a part. It's a small part, they can manage it, and in the end, they combine it together to have the one large program. Now, these sections are known as either subroutines, functions, modules, or procedures. So those 4 terms are basically referring to what I just explained, breaking off the program into parts. Now, a subroutine is a named section of a program that you can repeatedly call on to perform a given set of instructions. So, if we were to illustrate this here once again, we can say that this here is subroutine 1, this here is subroutine 2, this here is subroutine 3, this here is subroutine 4. Now, what can happen is that, well, obviously, as I said already, one person makes this one over here, another person makes this one over here, and when they actually write in the line of code, so this box over here is like the line of code, they could say, welcome back, Subnut. They can say that they could run S1 first, they could run S2, and they could jump to S4, they could jump back to S3, and they could call back S2. So that is why they make it modular. That's what they call a modular program, because the program is in parts so that they can call upon any one of these parts now. That is the advantage of making your program using subroutines. Now, sometimes it returns information to another part of the program, such as accepting a number. Well, that's basically what I just explained there. So, using subroutines saves writing the same code several times in the program, because you can basically call on that part of the subroutine or that module later down in the program instead of writing it back again. That's actually one of the methods of making an effective program. You minimize the lines of codes in your program. So this method of focusing on the program main goal and then separating the program into manageable components, this is called divide and conquer, or the top-down design. So divide and conquer, you're splitting up the programs into parts so that you can perfect each part and make a more effective program. Now, the individual subroutines, they can be tested in isolation to check to see if they are working. So if a part of the subroutine does go bad, you could always blame that person and say this person didn't make it properly and so on, and that person would just have to go and fix issues inside of it, instead of having to go through the entire program and wonder which part of the program is actually causing the issue. Good, so we're finished with another chapter here. A lot of details on how to design a flowchart or algorithm. Remember, an algorithm can be represented with a pseudocode or a flowchart. We gotta be precise, and remember, it's an expansion of the IPO chart. These are the steps you follow to basically make it effective. Remember, we looked at a variable and a constant, and the types of variables or constants we can have, and then what are the various statements and keywords in our algorithm that we put into our algorithm. Great. So now we're getting into actually creating a pseudocode. Are we clear on all of this information before we move on?
Yes, sir.
All right. Let me see if I can find this document. Problem solving. I had created a table that shows you the yeah, that's what we can basically use. Good. So I'll come back to that. So a pseudocode. What is a pseudocode? How do we develop a pseudocode? Well, a pseudocode is not a programming code, is not a programming language. It is basically a guide as to how to create your program. But it uses English words as mentioned and phrases that are clear enough that you can easily convert it into your program. So remember, you have to use statements, you have to use keywords, you have to use variables, conditional statements, and loops in order to design this pseudocode. Pseudocode can also be developed from the IPO chart. Now, it's not necessary for you to develop an IPO chart, but as I mentioned earlier, it helps to guide you. What is your input, what is your processing, and what is your output. So we're going to quickly run through some of these examples here as to how to develop a pseudocode. So we see the IPO chart here. We have the first column input, second column processing, add three numbers together, and the third column the result of the addition you want as your output. Now, this example here is the pseudocode for that IPO chart. I should have left the steps. So whenever you're creating a pseudocode, you would also number them, like you just saw, like this here, because you want to know what are the steps in your pseudocode that you would follow. So if you notice, the very first line is your title. This here is some steps that I developed. Whenever you're creating a pseudocode, this is basically the layout. This is my guide to creating a pseudocode. First, you have a title, because remember that title is to indicate the start of your pseudocode. The title indicates the start of the pseudocode. Now, after you would have indicated the start of your pseudocode with that title, you declare your variables. After you indicated the start, you declare your variables. So declare or declaration of variables basically means to give the variable a name and give a data type to that variable. That is what is meant by declaring a variable. Then next, if necessary, you initialize your variables. This is where you initialize your variables, right after declaring. What is meant by initializing a variable? It means to give the variable a value. So title, declare your variables, and then initialize your variable. Then the fourth step, this is basically the body of your this is basically going to be the body of your program. This is where you're gonna put in all of your input. In most cases, whenever you're going to make an input, you give some instructions before the input. Like for instance, when you guys were developing your SBA, you would tell the person, please enter a number, please enter a name, please enter your last name. That is called giving instruction or prompting for input, because you want the person to know what they have to put into the program. So even before you input, you're actually given some form of output as instruction. So in the body, you start off with your input, and then you carry out your processing to give you your calculation, because obviously you could only process after you would have collected your input. So it's logical. And then you give your output after you would have finished your processing. and then finally you end your pseudocode. You put end, you put stop to indicate that this is the end of my pseudocode. So this is the general layout of how you would create a pseudocode. So in your exam, they ask you to create a pseudocode. These are the steps that you would follow. These are the parts that your pseudocode should have to be effective. If you have any questions on that, let me know. So we can look at this example here. So if you notice, we're numbering each step. So once again, at the top here, we have our title indicating the start, pseudocode 5A, add 3 numbers. If you notice, the title starts with the word pseudocode, colon, and then whatever title you want to give it. That's how we design the title, pseudocode colon and the title. Now here we have input number 1. So notice these keywords here, input. That's basically indicating we're putting a value into the variable called number 1. Now in these examples, they don't show any example of declaring, they don't show any example of initializing. So I can actually create one for you guys and show you the steps of creating one. So step number 1, so you want a title. So pseudocode add 3 numbers. So well, firstly, what I'm going to do, I'm going to create a pseudocode to show you guys an example. Notice I'm going to follow all of these steps over here. So our title there, add 3 numbers. Next, I am going to declare my variable. So normally I would put it something like this here, put it as a title. We can say variable declaration, and it's not necessary, but it's good to like organize your information so that it's easier to follow. So variable declaration, and then you declare your variables now. So number 1, and it's equal to what type of data, integer or real. So in this case, I want it to be an integer. Now number 2 equal integer, and number 3 equal integer. So I'm declaring 3 variables here. So you could do it in this method here, or you could do it like this here also. So if more variables have the same data type, you could group them together in the same line like this here, and then state the data type. Either method can work because they're all the same data type, so you can put them in the same line. So this will only work if the variables have the same data type. So next we have variable initialization. So remember, if you have any questions, let me know. Variable initialization. At this step here now, we are going to initialize any variable. Now here, as I said already, variable initialization is not always necessary, because in this case here, I don't need to initialize these variables here, because I am going to input the value. The person that using the program, they're going to input the value. But if you do need to initialize a variable, for example, VAT is equal to 14. But it's good that I brought this up also. Whenever you are initializing, you do not use the percentage symbol. So we should know that for like normal operations, you would use the plus sign for addition, the hyphen sign for subtraction, the asterisk for multiplication, the slash for division, and so on. Similarly, you do not use the percentage symbol, because percentage symbol is actually a operation called modulus. So if you put that in a program, actually it would not recognize it. So like, say for instance, whenever you have to initialize a value with a percentage, you simply convert it into the decimal format like that there. So you say that is equal to 0.14, and that way you can make use of a percentage. So any value that you need to use, so for example birth year is equal to 2000, that is how you initialize a variable. Now the next step is input. So you can put input there, and well, obviously we need a output keyword because we want to say output, and we want to put on the screen that please enter the first number. Now if you notice, that phrase there is put in quotation mark. Now whenever you're starting the body of your pseudocode, that is when you're going to start numbering the steps. So this is basically going to be step 1, step 2. This is where you're going to accept the input, and you say that's going to be stored in a variable called number 1. Now if you notice, the variable's name is not in quotation mark. So only phrase and words and characters that you want to appear on the screen is going to be placed in quotation mark. Any variable that you're going to use and you need to output on the screen, it needs to be by itself, no quotation mark. So step step 3 now, the same output, please enter the second number, close quotation mark. Now if you notice, I'm using the semicolon. It's not necessary, but it's a good practice to show that's the end of that step there basically. But I would advise you don't make use of it, because you might accidentally use it incorrectly in your exam. Because like for instance, the if statement, you actually don't put it at the end of each line. So in order for you, if you don't remember, just don't make use of it, because it's not necessary in a pseudocode. So input number 2 is only necessary in most cases for when you're actually creating the programming language. So if you do see it as an example, you could say that it's actually a programming language that you look at. But then we never know, CSEC might trick us and they might actually put it in. So it's good to know what it actually does, indicating the end of a line of code. Input number 3. Important to note that variables can be case sensitive. So whatever you create the variable as, ensure you name it exactly like that. So this is our input and our output, our accepting that input part. So now we can enter the processing part of our algorithm. So in the processing now, that's where we're going to calculate, carry out a calculation. The purpose of the algorithm is to add these 3 numbers here. So I did not create a total variable. So total is going to equal to integer, and I can even add it here at the end, total. So remember, this is another example. So here now, total I can say is equal to 0. Why? Because I want this total value here to start off with 0. I don't want it to have anything inside of it when it is running in my program. Now in the processing now, I'm going to put total is equal to number 1 plus number 2 plus number 3 semicolon, indicating the end of that line there, and then I have my final output here, and at this section here I can see outputs. So I didn't number the steps here, so that should be step 7. So if you notice I'm missing any step, you can just let me know also. Step 8, we're gonna output keyword output, and we're outputting that variable total, and then finally we have end, indicating the end of our pseudocode. So look at the steps on the left hand side and ensure we have everything. So 1, we have our title, which indicates the start. 2, our declaration of variables, that's what you're seeing here. We state the name and the type. 3, we initialize the variable, that means giving the variable a value. And then when you enter the body now, that is when you're gonna list all of your input, your output, your processing, and so on. So you can see here we have our input and outputs. This is called prompting. You're telling the person what to put into as input, and then we accept that input into this variable called number 1, number 2, and number 3. At the processing now, what happens is that the calculation is on the right hand. Unlike what we are accustomed to the calculation being on the left hand and the result in the right hand. But in pseudocode and programming, it's reverse. The calculation is on the right hand and the result is being stored on the left hand. So they're adding the 3 numbers here, and it's being stored in the variable called total. And then finally we output what is inside of that variable called total. Good. Does anyone need any clarification on creating this basic pseudocode? Any questions, concerns, comments, anything? Alright, I'll take that as a no. So if you look at this example here, notice we're inputting three numbers here. We're adding these 3 numbers here, and then it doesn't say where to store it, but it does simply say output the result of adding those 3 numbers together, and then finally we have the end statement there. Alright, let's look at another example. So this example actually summarizes the one above. So like I said, you can input, even the input, you can actually group them together like this here. Input number 1, number 2, number 3. But when you do that, when you do put it like that, you would not get to give the prompt like how I have the prompt here to tell the person to give the input, because everything is basically grouped as one there. But here we're adding these 3 numbers together, and then once again it's the outputting the result. Alright, so another example, we're inputting and we're storing the value into 3 variables here. And notice we have the arrow. The arrow is basically the same as the equal sign. You can either see an arrow or you can see an equal sign, but the arrow actually visualizes it better for you because it's showing you the direction. It's showing you that the calculation is on the right hand and you store it on what is on the left hand side here. Follow the arrow there basically. Alright, so you may see an arrow, you may see an equal sign. Now notice they're now using the keyword read. So remember, those 2 are used for input. It's either input or read. Those are used to indicate you are inputting some sort of value in the algorithm or program. And notice they are using the equal sign here now, adding these 3 numbers together and storing it in a variable called result. And notice the keyword print. We are outputting the variable results. Now, sequential statement. What is a sequential statement? Sequential basically means one after each other, and that is basically how your pseudocode, your program works. It executes one line of statement, one line of code, one after each other. So that's why you got to put what should happen first in the beginning, what should happen in the logical order basically. Alright, another pseudocode. Here we have input indicating that we're inputting something. We are storing a variable, a value in the variable called max temp, and another value in a variable called min temp. And on the right hand, we're carrying out a calculation, and we're storing it in a variable called average temperature. And then finally, we output that variable, whatever is inside that variable. Remember, whenever you use a variable name, you're using what is inside of it, not the actual name of the variable. So what is the value inside of it? Remember, once again, you have any questions, concerns, let me know. Good. So we're moving on to the conditional statements now, or the conditional branching. Conditional branching or conditional statement, what we just learned, the if statement. Now there are two types of conditional statements. You have the if then and you have the if then else. Very important to note is that then represents true and else represents false. So if you ever see a then, that indicates true. If you see a false, that indicates if you see else, that indicates false. So what is the structure of an if then statement? The structure is that you're going to see it starts off with an if, you're going to see then, and so the if is going to have a condition, it's going to have a test. So for example, let me show you. If total is greater than 50, this here is our condition. If total is greater than 50. Now going back to the structure, after the condition, you're going to see the keyword then. Remember, then is true. So only if the condition is true will we carry out the statements that is under then. So for example, if total is greater than 50, if it is, now say for example total is 60, that means total is greater than 50. So what we're going to do, we're going to carry out the then statement, and we're going to print total because it is true. We're carrying out the then statement. Now what if it was false? What if total was actually 40? This means the condition is false. That means we ignore this line here because this line is only looking at if the condition is true. So we ignore this line here and we go to the next step. The next step is to end the if statement, and then we end the program, end the pseudocode. So if then, it only looks to see if the condition is true, and you carry out what is under the then statement. If it is false, you basically look for where is the end of the if statement and then continue from after there. That's the if then statement. Now let me see if they indented. No, they didn't indent there. Good. So we have the general format here once again. So the if statement is only looking to see if it is true, and then if it is true, then carries out T statement, which is basically true statements. So if the condition is true, execute the true statements. What's a condition? A condition is a Boolean expression, which means it could only have one of two states. It could either be true or it could be false. Like for instance, when you're checking to see if something is less than, if it is more than, if it is equal to, it's always one of two states. Either it is false or it is true. And true statements basically are one or more statements that are going to included only if the results of the condition is true. You use end if to tell the computer that the if then statement would have finished. Now if the condition is false, we're going to skip the true statement as I mentioned and basically continue with the rest of the program. Another example of the if then statement, we have a variable called age. Say for instance we enter 18, we reach a condition here. Is 18 less than 13? False. That means we ignore the then. We go to the end if, and then we end the program, end the pseudocode. We try it again. We enter 12. Is 12 less than 13? True. That means we carry out the true statement. We output student is not a teenager. That appears on the screen. We reach the end if and the end of the program. Another example, we have the year 2019. We input a birth year, say 2000. We carry out the calculation. This year, which is 2019, minus 2000, that's 19. Is 19 less than 13? False. So once again, we ignore this true statement. We go to the end of the if, and we end the pseudocode there. I'm not seeing any indent to show you guys. Alright, another example. Mark is greater than equal to 80. So once again, if it is 90, then that means it is true. So we output excellent, and then we continue, because remember we're going logically, one line of code after the other. So we output please see your teacher. Then we end the if, and then we end the pseudocode there. Now this is what I was looking for. So notice here the pseudocode is indented. Indenting is used to indicate what statements fall under what keywords. What keywords fall under what keywords, basically. So this here is indicating these two output is under this then keyword, so that it makes it more clearer for us to read and understand the statement. So now once again, if it is 90, then that means it is true, and these two outputs are output on the screen there. Good. So if you guys are clear on the if then, we're going to move on to if then else. So if you notice now, else now appears. So if you realize, so far we were ignoring the false. So that means now we are considering the false. We are looking at both if it is true and if it is false. So what is the structure? Well, if once again is going to be our condition. We're checking to see if it is true, if it is false. Now if it is true, once again as mentioned, we carry out the then statement, and if it is false, we carry out the else statement. So let's look at an example. So here we're adding three numbers together. We are putting in three numbers, read number 1, number 2, number 3, add them together. Now say the total is 60. What do? Is 60 greater than 50? That is true. So we look for the then statement. The then statement says print total. Now remember, it is true, so whatever is in else, we ignore it because it's not false, and then we go to the end of the program. Now once again, say the value is 40. Is 40 greater than 50? False. What does that mean? We ignore the true statement because it is false, so we ignore then, and we carry out the else statement, which is for false. So we print the sum is less than 50. If any questions on that, let me know. Moving on to the next example. We input the birth year, we input the this year, we carry out the calculation. Say for example the age is 11. Is 11 less than 13? True. So we carry out the then statement. Millie is a teenager, and we ignore the false statements. We go to the end if, we end the If it was 15, is 15 less than 13? False. So we ignore the true and we carry out the false statement, which is else. So we output Millie is not a teenager. Any questions on that? Let me know once again. So what is the general format for the if then else? We have if, which is going to be our condition, then, which is going to be our true statement, else is going to be our false statement, and end if indicates the end of our conditional statement. So that brings us to the end of conditional statements. Now, next we're moving on to nested conditions. What is a nested condition? A nested condition is basically when you combine conditions together, when you combine statements together. So basically, you put in one statement within the other. So we have an example here. So let me know if you're following it. So we have input, we're putting in a grade into the variable mark. So say for instance, we put in 50. We have 50 here. We come to our second step. So that's our first step. Our second step, we're testing if 50 is greater than or equal to 80. That is false. So remember, once again, we ignore the true. We have to ignore this here also because it's on the then. Remember that all of this is true because it's on the then. And then we go to the false, which is else. So on the else, if you notice, we have another if statement. So this is called a nested condition. Within the else, we have another if statement. So here now we have to carry out the other if statement. If mark is greater than 70, so remember we entered 50, we're testing again. Is mark greater than 70? That is false. So we ignore this true part here because it's false. And then we go to the next line, which says, please await the end of term reports. So once again, nested basically means to put a statement within a statement. Put a condition within a condition. Anybody need me to repeat that?
No, sir, but one question. The second if function, you don't need to end that one. Or does the last end if goes to both of them?
Yeah, that one would go for both of them. Because if you notice, it's out here. So that's indicating that it's the end of this one here. And remember, this is inside of this if here basically. And
okay.
Yeah, it's not always necessary to have end if, but the end if is like for you personally, and for anybody that is reading it to know that that's the end of the if. So if you had actually wanted, if you notice, this is actually the two conditional statements. This is the if then else statement, and then this is the if then statement. If you guys notice that. The if then else and then the if then, because if you notice, the second if does not have a else part. So at like around at the end here, they could have indicated an if they wanted. It's up to you for your design purposes if you want it in to indicate that's the end there, because it would have indicated, would have been more clear that this is the end of this particular if statement. But it being outside here, this indicates that this is the general ending of all of the if statements here. Alright, if any other questions, remember, let me know. Good. We're moving on to loops now. Now, what is a loop? Remember, a loop is basically repeating a certain part of your code, certain part of your line of code, certain part of your pseudocode, a part of your program. So most loops are actually made up of these four parts here. One is going to have a starting value. So this value here is going to start off the loop. It's going to start with this particular value. So it's going to have a variable that is going to have a value, and this value is actually going to be used to monitor the loop, so that this variable will actually update, which is the last step. And when it updates, it indicates that the loop is actually cycling through. The loop went through 1 time, 2 time, 3 time, 4 time, and so on, because the value keeps updating. So you have a starting value, which is a variable, and then you test that variable now. So you test it to see, should I go into the loop or should I not go into the loop? Now when you do get into the loop, you execute the loop, and then when you're finished executing the loop, or even when you enter, you always got to update the value of that variable to indicate that you would have entered that loop. So these 4 parts here, these 4 components, make up basically any loop. A variable that starts the loop, that monitors the loop, something that functions as a test. You can think of the test like a gate, so that you have to pass this test here to go through this gate. When you do get into the gate, you execute the program, and then you update that variable to indicate you would have went through the gate, went through the loop. Now we have 2 types of loops. We have the indefinite loop and we have the definite loop. Indefinite meaning you do not know how many times the loop is going to run for. You don't know if the loop is going to run 10 times, 50 times, 100 times. You don't know. So those loops, examples of them are going to be the while and the repeat loop. So when you do not know how many times you should repeat for, you use the while and the repeat. Now the definite, you already know in advance how many times it should repeat for. You already know that it should run for 10 times, it should run for 20 times. So an example of that is going to be the for loop. So firstly, we are going to look at the indefinite loops. Now what you got to know about these loops is the differences between them and how they work. So the first difference between the while and the repeat is where is the condition. So if you notice, both of them have their start value in the beginning. They have the start value, and remember that's the start value up here, the first part here, the starting value. Then next, they have a condition. Remember the gate, they have this condition to check to see if they should enter into the loop. So that's the condition here. But notice for the 2 of them, the condition is at different location. The while loop has the condition at the beginning, and the repeat loop has the condition at the end. So that's one difference there you should remember. So if the condition is at the beginning, that means the statements are after that condition, or they are more at the end of the while loop. I don't want to say end, it's more of the after the condition. It's more after the condition. And these statements here for the repeat loop are before the condition. So that's the other difference there. So you have 2 differences here that you should remember. Where is the condition? While loop has it at the beginning, repeat loop has it at the end, and where is the body of the loop? Where are the statements of the loop? The repeat has it before the condition, and the while has it after the condition. So the while loop is going to repeatedly execute 1 or more statements as long as the condition is true. So the other difference, the has to be true, the condition has to be true to continue the loop. It's going to repeatedly execute 1 or more statements as long as the condition is true. So you have to remember, when does a while loop continue? When the condition is true, it will continue the loop. The condition in a while loop is tested at the beginning, as I mentioned already. So it is possible for the statement to not be executed at all. So that's another difference there. How many times can the while loop run for? It's a possibility that it would never run. So it's a possibility that it can run for 0 times. That's a possibility there. Now for the repeat loop, let me jump to that one so that we can talk about the difference, and then we get into how they actually work. So the repeat loop construct repeatedly executes one or more statements as long as the condition is false. It's going to repeat once the condition is false. And note that this condition is tested at the end, as I mentioned already, so the statement will always be executed at least once. So, going back to the differences, this one, it has to be false, and it can run for 0 time, and the repeat can run for 1 time. So those are the 4 main differences that you should remember. The while loop has the condition at the beginning. It has to be true in order to repeat or loop. The conditions are after, the statements are after the condition, and there's a possibility that it will never run. It can run for 0 times. It's a possibility that you never enter the loop. So they might ask you that question: which loop has the possibility of running 1 time? That is the repeat loop. Why? Because the condition is at the very end. The condition has to be false for the loop to repeat, and the statements are before the condition. So if you were to actually visualize that, so while and repeat, imagine a gate. So we're going down, and the while, so the condition is at the beginning. So say the test or the condition is at the beginning, and the repeat has the test or the condition at the end. Now, so that means the statement is here. The statement is here. So the statement is after the condition. The statement is before the condition for the repeat. Now, because of the while loop, it has to be true. So it got to be true in order for you to enter the gate, in order for you to enter the loop, and it has to be false for you to remain inside of this loop here, because you won't exit if it is false. You gotta be true in order for it to exit. So if it is true, you come out of the loop, and you can say if this one here is false, you do not enter the loop there. So if you can see it from visually here, because the test is at the very end here, that means we can go through the code at least 1 time, because the gate or the test is at the very end. You can go through it at least once. But for the while loop, it's at the very beginning, so it's the possibility they can lock you out at the very beginning here. So it's a possibility you always get false and you never enter the loop. Alright, are you guys following on the main differences there?
Yes, sir.
Alright, so let's look at some examples of them now. So what's the format of the while loop? Well, we have the while keyword, we have the condition, you have your statements, and then your end while. So let's look at this example here. So remember, we need a variable that monitors the loop, that keeps track of it. So that's our number equal 1. If you notice, it started off with this value here. So next we have the condition. Is number less than 3? Yes, it is. So that means it's true. Remember, where is our image? Remember, if it is true for the while loop, what do? We enter into the loop. So this here is true. We enter the loop. The begin is indicating the starting of that loop. So the first statement in the loop, we add number plus 1. This is actually the update. Remember, we talked about the 4 components. So this is our starting variable. This is the condition. This is the update. And this here is the body here. This is the end of the loop. So number plus 1, that's updating the variable to indicate we're going through the loop. And then finally, inside of the loop, we have output, the number is, and it's basically a print here, printing the output on the screen. Now end while. Now because the condition was true, we got to repeat, we got to go back from the top. So this would have actually been 1 plus 1. So from 1 plus 1 now, we go back to the top, and we're at this stage here now. Is 2 less than 3? True once again. And then we go through the program. Eventually we're going to reach is 3 less than equal to 3? That's true once again. We go through the loop once again. And then when we reach 4, that's going to be false. So we do not enter into the loop, and we come outside of the loop, because remember, we got to continue the program, and we reach output out of the loop. So that is how that loop works. If you have any questions on it, let me know. Another example, we have the starting variable again. Age is equal to 15. We're testing to see if age is less than 20. Now is 15 less than 20? True. So that means we enter the loop. We carry out these actions here. We print you are a teenager. We update the variable age plus 1. Now eventually, while looping, you're going to reach 16 true, 17 true, 18 true, and eventually we're going to reach 20. Is 20 less than 20? False. So that means we ignore all of this and we reach outside here. You are not a teenager. Any questions on that? Let me know. Another example. So we enter a mark and say the mark is 60, while mark is not equal to -1. So 60 is not equal to -1. It's different from -1. So that is true. We enter the loop and we carry out all of this action here. Now once again, until it is false, -1 is not equal to -1, then we end the loop and we come out here. Good. So that's basically the while loop there. Remember how it works. Going back to the diagram, it has to, at the very beginning, has a test. Once the test is true, you enter into the loop and carry out the statements inside of it. Now the repeat loop now, how does that work? Remember we said that you enter into the gate, you enter into the loop in the very first beginning, you're already in, but the condition is at the end. And if the condition is true, you exit, and if it is false, you continue inside of the loop. So let's look at some examples now. So repeat, notice our starting variable there. Repeat, notice no condition is here. We enter the loop right away. So we enter the loop, we update the variable number plus 1, we output the number is what? Until Now repeat has a keyword called until, so it's basically repeat until. So if you notice, the while loop has while and then it has end while. That's indicating where it is starting from, where it is ending. But the repeat doesn't have an end repeat, it has an until. The until is kind of indicating where the repeat is ending. So it's basically repeat until number is equal to 3. So the number here is going to be basically 2 is 2 equal to 3. That is going to be false, so it continues the loop. As remember, if the loop is false, remember if the condition is false, we continue the loop. So that there is false, 2 is not equal to 3, we continue the loop. So eventually we're going to reach to is 3 equal to 3, that's true, so that means we come out of the loop. So if you kind of realize what's actually happening, it's kind of like whenever it is true, you actually continue the line of code whenever it is true. Because even for the while loop, if this was true, you continue with the logical part of the code whenever it is true, whenever something is true. So that's kind of like a pattern that's happening there. Another example, repeat. We enter the line of code, output attend classes, and we're repeating until day is equal to weekend day. So if the day was Saturday, then that would have been what? True. So that means we come out of the loop there. Another example, so repeat, we input a day, the day is Monday, output do not go to school until it is a school day. So now Monday, that's a school day, so that's true, and we come out. So if it would have been Saturday, Sunday, then that would have been false, and we continue the loop once again. Another example, we have a variable equal to 18, we enter the loop, we output you are under 20, we update the variable, it gone to 19, is 19 equal to 20, that's false, so we continue the loop. Remember, once repeat is false, we continue. So eventually we're going to reach to age being 20, and that's going to be true, and we exit the loop. Alright, another example, repeat, we enter the repeat loop, we display enter a mark, we input the mark. This is a combination of loop and condition, combination of the loop statement and the conditional statement. We input a mark, say we input 60, if mark is equal to -1, is mark equal to -1? False. So we ignore this true part here, because remember it's false. We go to the then else part, because that's false. We carry out these statements here. Now we're supposed to be repeating until mark is equal to -1. Now 60 is not equal to -1, so once again that's false. And remember, when the repeat is false, you repeat the loop. So we gonna back to the top once again. So we're back up to the top once again. We input a mark, say now we input -1. If mark is equal to -1, that's true, mark is equal to -1, so we carry out the then statement, we display end of marks on the screen, we ignore else, because remember it is true. So this here now Is mark equal to -1? Yeah, because we did enter it as -1, so that's true. So we exit the loop. We reach to another if statement. If count is equal to 0, well, we weren't focusing so much on count, but if it was equal to 0, if it was true, we would have done this part here, and if it is false, we would have carried out this part here. So whenever they give you a pseudocode, you have to create one. The main point to remember is that it has to be logical. If you notice, everything is logical that we're following, one step after the other. Remember, if you have any questions, comments, let me know. Next, we're moving on to the for loop. The for loop, remember, that's a definite loop. We know how many times it's going to run for. So this loop, we are going to indicate a starting value and an ending value. We're going to indicate this is where it's going to start from, this is where it's going to end. It's going to start from 1 to 10. It's going to start from 20 to 10. A starting value and an ending value. So the general format for the for loop, it's for, you have a variable. All loops have a variable to monitor the loop. You indicate the start value, and then you use the keyword to or down to. So if you're going to go from going up, so 1 to 10, or 10 down to 1. It all depends on what direction you're going in. And then you have the do statement, the do keyword. So for some reason they added that do keyword at the end of the for loop. So for loop always has that do at the end of it. Now note, the variable must be in order. So you got to be in some sort of logical counting order. The variable begins with the start value. The variable changes by 1. Now remember, if you notice, if you can remember, the part of the requirement of the loop is to update the loop. You got to update the starting variable, the variable that is monitoring the loop. And in a for and a while loop, as I said already, this is how you update it. You basically add 1 to the variable because you want it to increment by 1. So you have to manually update it. But in a for loop, you do not use that kind of statement because the for loop knows that it's going you're counting. Basically it knows what is the starting value, it knows what's the ending value, so it will automatically increment for you. You don't have to tell it to increment. It's going to automatically change 2, 3, 4, 5. It's going to automatically count down 10, 9, 8, 7, 6 and so on. So it automatically changes by 1 every time. And the loop terminates when the variable reaches that final value. Because remember, you're telling it loop from what starting value to final value. And then you use an end for to indicate the end of that for loop there. So an example, you have your variables here, Saturday equal 2, Sunday equal 3. For loop, day, so that's your variable day. If day is equal to Sunday to Saturday, so that's 2 to 3, starting value 2, ending value 3. Do output, it is a weekday. So not making much sense. Let's not spend too much time on it. Let's look at a better one. So for countdown, this is our variable here, countdown. So countdown, that variable is going to start with 10 and it's going to count down to 1. So if you notice here, it's going to count down this way when we output that variable here, 10, 9, 8, 7, 6 and so on. For loop, we have a variable called time. Daybreak to sunset, do. So daybreak is the starting point. So when daybreak starts, it's going to output it is not night until it reaches sunset. When the sun goes down, then it's where it's going to exit the for loop. I guess similarly for This one here is looping from Saturday to Sunday, checking to see if it is weekend, and if it is, I guess, not weekend, it would come out of the for loop there. Another example for the variable number counting from 1 to 2, do is going to output the number is 1, because remember it starts at 1, and it's going to loop, and then it's going to reach 2, and then it's going to come out of the loop because 2 is the last value. So then it's going to print out of the loop, end the loop, and then end the program. Another one. So here we have, let's see what's happening. So we have sum is equal to 0, count is equal to 1. We have a repeat loop. So we open the repeat loop and we start a if. If count is even. Now count even, that is false because count is 1. So we ignore this then part here because remember the answer is false. So the exact pattern you guys see me doing all the time, this is how you should carry it out in your exam. Ensure you label everything so that you understand what is the flow, what's happening. So now it is false, we ignore the then. So we go logical. Remember, we go logical. We go to the next line of code. So we do count equal count plus 1. So we updated this variable now. So now it's going to be 2. Now we're supposed to, this is the end of the repeat loop. It's repeat until count is greater than 2. So now 2 is equal to 1. So now we got to update it at the top here. These things you got to do for your exam in order to remember what is happening. So now count is no longer 1, count is now 2. So we got to go through the loop again. Now the question is, repeat if count is even. Is count even? True. Count is even because count is now 2. So that means we execute this then statement. Then is sum plus count. So that's 0 plus 2. And that's going to be 2 inside here now. So up here is now going to be a 2. So now we come down back here to this line here. Count equal count plus 1. So that's going to be 2 plus 1. So that's going to be 3 there now. 2 plus 1, 3. We're supposed to repeat until count is greater than 20. 3 is not greater. And we keep repeating this cycle over and over and over until count is greater than 20. For example, if it is greater than 21, then we reach true and we display whatever is inside of sum. Are you guys clear on that? Following so far?
Yes, sir.
Yes, sir.
Great. Alright, so that brings us to the end of that there. Alright, what we're going to do, we're going to take a break because we covered a lot of information here. If you have any questions, concerns, comments, suggestions, let me know now. We're going to take a 5-minute break and then we're going to continue with flowcharts.